Welcome to
Family Math number 86.
Family Math number 86. Okay, so what we've got today is actually the Mathematical Association of America's Minute Math problem. It's a cool problem, and it's from a test for 10th graders. And only about a third of the people got it right, so it's pretty challenging. You guys up for the challenge today?
Yes.
All right. The 5x5 grid shown here has a collection of squares from 1 by 1. You see the 1 by 1 square? To, like, here would be a 2 by 2.
Yeah.
You see that? Show me a 3 by 3.
3 by 3 over here.
Good job. Okay, now I'm going to mash them together a little bit. Okay. So the question is, how many of these squares that are in this grid here contain the red center square? You see that red center square?
Yeah.
Okay. So what do we have to do in this problem? What kind of problem is this?
It's a counting problem.
It's a counting problem, so we have to count.
We know all the
each 3 by 3 contains it.
Okay, well, let's talk about some ideas first, and then we'll go. So each 3 by 3. So show me a 3 by 3. There's one. Okay, show me another 3 by 3 that contains it.
This.
Oops, that one there. Okay.
Like that.
All right.
And there's that one, and then
There's 2 more.
Okay. So we see that some 3 by 3s contain it. Do you see any other kinds that contain it?
well, there's
There's the 3 by 3 in the middle.
Yeah, there's a 3 by 3 in the middle that
there's
contains
this
it.
2 by 2, this 2 by 2, this 2 by 2.
There's a lot. There's going to be a lot of squares that contain it.
There is going to be a lot of squares and they're going to contain it. So on counting problems where we have lots of things to count, what's an approach that we really like?
We can make a chart.
We can make it simpler.
We can make a chart. We can make it simpler. How do we make it simpler?
Well, we could only use a 4 by 4.
Ah, okay.
We could just boil it down just to 1 by 1.
Yeah, we could make it simpler. In this problem, though, since it's a very specific problem, if we were having trouble figuring it out, we could go to a simpler problem. But we're not quite having trouble yet. So I think making a chart is a great idea. Can you hand me that eraser there? Actually, can you erase? Because I don't want to reach through the tripod. What do we want to make in our chart?
We could make the
number of squares that...
Well, you guys saw some 3 by 3s and some 2 by 2s.
yeah.
Number
We
of
could do
squares.
charts of 3 by 3. We could do 2 by 2s,
and 3.
1 by 1s, 2 by 3s, 4 by 4s.
Okay, so where would be a good place to start?
Just 1 by 1.
Okay, so 1 by 1s. So we're just going to make a chart. So we're going to go systematically, right? Let's take a look at how many 1 by 1s contain that red square.
1.
Just 1.
Are you sure?
Yes.
Okay. There's only one by 1, so that's easy. So the 1 by 1 squares, it's just this one. What's next in our chart?
2 by 2s.
2 by 2. See, now you guys started by saying, let's look at 3 by 3s, but the 1 by 1's easy. The 2 by 2, okay, how many 2 by 2s? Let's see if we can figure this out.
Well, there's 1.
1 here.
Yep.
Okay.
2 here.
2.
And then
3.
3.
And 4.
4. Okay, so it looks like there's 4 2 by 2s. Okay.
Then there might be nine 3 by 3.
Oh, how interesting. And I see a little pattern. 1, 4, maybe 9. Let's see if we can count the 3 by 3s. Now we're going to have to be careful
There's
here.
4 around the edges. 1. This one. This one. This one.
I mean that one.
Okay, well let's be. There's one in the middle. Okay.
5.
So you saw the 4 around the edges. You saw this one, right?
Yep.
You saw this one.
Yeah.
You saw this one here. And you saw this one here. Okay, and then you also noticed this one in the middle, right?
Yeah.
Okay, so that's 5.
And then you could go here, 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 and here.
Ah, so then there's these ones too. You see that one?
Yep, they don't include the corners.
That don't include the corners. 1, 2. So how many is that?
That's
That's 9 of them.
It is 9. How about that? Now, if you wanted to be sort of, again, systematic about counting this, you might just count by going around the square like this. Okay, so maybe count this one as number 1. Sorry, I'm getting 2 hands here. This one is number 1. This one is number 2. This one is number 3. This one is number 4, 5, 6, 7, 8. Oh, where's number 9? It's the one in the middle. Okay, great. Now, how many 4 by 4s? What does it look like our pattern might
There
be?
should be 16.
Maybe there's 16, but
there's
I'm
only
not.
one 5 by 5.
I'm not. Right, exactly. There's only one 5 by 5.
So it could be 1, 4, 9, 4, 1.
It could be 14941. So there's only, our pattern of squares isn't going to continue. That's a very good observation. 149, 1. There's only one 5 by 5. There's not 25 5 by 5s, right?
Yeah.
So let's see. Can you point out a 4 by 4 square?
There's one here.
Pull it up. Pull it up. That one there. There's one there. Okay.
And there's this one.
All right. Awesome. Pull that up. Probably need 2 hands. Here, I'll do it. All right.
And there's a third one.
There. Okay.
And then this fourth one inside. That's
Fourth
kind
one down here.
of hard to pull out.
Yeah.
Yeah.
Oh.
So there's 4.
There's just 4. And the reason we know that's all there is, okay, so we've got this one, right?
Yeah.
That's the only one that's going to contain that corner.
Yeah.
And
Okay,
Same
so
for the others.
if we do what I talked about with the 3 by 3 and start walking around this way, well, what other one contains this piece here? Only that one. That's all there is, right?
yes.
Okay. So there, that gets us first. So the pattern did go 14941. Okay, so how many is that?
That's
Well,
one.
it's there's 2 plus 8. There's 19.
There's 19. Do you see how that got this 19?
Yeah.
What's 1 plus 4?
5, and then there's
Not-
2 of those.
Oh, 5 plus 5 is 10.
10 plus 9
9
is
is
19.
19. Okay, great. Hey, only a third of the people got that right, and that's a problem for 10th graders. So, systematic counting. So first recognizing it's a counting problem, then making a nice little chart to make it nice and systematic, and then
And
Smashing the square.
smash the square. All right, good job, guys. That's a fun problem. I like that. I like those counting problems.